अस्सलाम वालेकुम। तो आज हमने कुछ न्यूमेरिकल सॉल्व करने हैं। पहला न्यूमेरिकल है डिटरमिन द रीजन इन z प्लेन रिप्रेजेंटेड बाय 1 इज लेस देन मॉडुलस ऑफ z plus 2 iota which is less than equal to 3. First of all, we will suppose that z is equal to x plus iota y. Then z plus 2 iota will become x plus 2 iota plus iota y, or we can write it x plus iota, take common from these two numbers, we get iota into y plus 2. Now modulus square of z plus 2 iota will be equal to x square plus y plus 2 का whole square. Therefore the z plus 2 iota modulus is equal to 1 will represent a circle with radius equal to 1 and center at 0 comma minus 2. And if we take this x-axis and y-axis here and this is origin, then this point is 0 comma minus 2. This is center of the circle and radius is 1. So the circle passing through minus 1 and minus 3 will represent this circle. Similarly, z plus 2 iota modulus is equal to 3 will be represented by the circle center at minus 2 0 comma minus 2 and radius at 3. So this is the circle represented by z plus 2 iota modulus is equal to 3. Now the region represented by these inequalities will be outside of this circle and inside of the circle. So the region in between these two circles, this shaded region, will be represented by this inequality. So this inequality represents this region. But you should note one thing, that less than equal to 3 and this is only less than 3. So the boundary of the outer circle will be included in the region, but boundary of the inner circle will not be included in the region. Second part is real part of z is greater than 3. So we want to determine the region represented by this. We know that z is equal to x plus iota y. So ये हम शुरू करेंगे सर. फिर हमने क्या करना है, real part of z. Real part of z is x. Now x is equal to 3 is a vertical line passing through x is equal to 3. If we draw it here, then this is x-axis, this is y-axis, this is 1, 2 and 3. This line is x is equal to 3. So if we want to plot the region represented by real part of z is greater than 3, it is actually x greater than 3. So it is all the region towards the right of this line x is equal to 3 in the z plane. So all this region, but this line is not included in this region. Region towards the right of this line in this z plane will be represented by real part of z greater than 3. Understand? Next is next question is, if z1 given is if z1 plus z2 modulus is equal to modulus of z1 minus z2, then prove that the difference of arguments of z1 and z2 is pi by 2. That is, argument of z1 minus argument of z2 is equal to pi by 2. This is what we have to prove. अच्छा जी, देखते हैं अब कैसे सॉल्व करना है. सबसे पहले इसको यूज स्टार्ट करेंगे हम कि हम सपोज कर लेते हैं कि लेट z1 प्लस z2 इज इक्वल टू r cos theta plus iota sin theta. We know that the sum of two complex number is also a complex number, and in polar form we can write any complex number like that. Similarly, and we suppose that z1 minus z2 is equal to r cos theta minus iota sin theta. This is equation number 1, suppose that, and this is equation number. Now, if we add these two equations, then we get what? 2z1 is equal to, what do we get? R into cos, suppose that this is, if we put theta here, we can put phi here. We can put theta 1 and theta 2. It's up to you. So it will become cos theta plus cos phi that's it. If we add them, because plus iota sign, and then we get plus r is common, so we get plus iota, and here we get sin theta minus sin phi. Now cos A plus cos B, using this formula we can know that cos A plus cos B is equal to 2 cos of A plus B over 2 into cos of A minus B over 2. Similarly, sin A minus sin B equal to 2 sin of A minus B over 2 into cos of A plus B over 2. Using these two formula here, what we get? If we use these two formulas here, we can write what we get. These two formulas here, 2z1 is equal to r, from here we get cos of theta plus phi over 2 into cos of theta minus phi over 2. And also this 2 will be here, so we got 2 cos of. Similarly, from here we get plus iota into, use this formula here, we get 2 sin of theta minus phi over 2 into cos of theta plus phi over 2. If we take this cos of theta plus phi, and also this 2 is cancelled with this 2, because this is here also, we can take common and cancel it, and we get to take this cos of theta plus phi over 2 common, so you get z1 is equal to r cos theta plus phi over 2 into cos of theta minus phi over 2 plus iota sin of theta minus phi over 2. If we compare this with this form or polar form, this is actually modulus of z1. This is the modulus of z1, and theta minus phi over 2 is the argument of z2. So this implies that argument of z1 is equal to theta minus phi over 2. That is the question number A. Okay. So from this is the, if we represent the polar form of complex number, then this is the modulus and this is the argument. So z argument of z1 is theta minus phi over 2. Now we want to find the argument of z2. Understand? इसको दोबारा एक रिपीट कर लो. देखें, हमने सबसे पहले शुरू कैसे करना है कि z1 प्लस z2 को हमने सपोज कर देना है r cos थीटा प्लस आयोटा साइन थीटा, और z1 माइनस z2 को हमने सपोज कर देना है r cos phi माइनस आयोटा साइन phi. So if we add these two equations, we get 2z1 and z2 cancelled, and again r is common, so we get cos theta plus cos phi plus iota sin theta minus sin phi. Now we have two trigonometric identities. Sum to product. Cos a plus b is equal to 2 cos a plus b over 2 cos a minus b over 2. Similarly, sin a minus sin b is equal to sin a minus b over 2 cos a plus b over 2. Therefore, using these two identities on this and this sums, you can convert it into product as 2 cos theta plus phi over 2 cos theta minus phi over 2. And similarly, this can be written as 2 sin theta minus phi over 2 into theta plus cos theta phi plus. Now, 2 is common, so 2 will be cancelled with this 2, and cos theta plus phi over 2 is also common, so we get r cos theta plus phi over 2, and inside the bracket we get cos theta minus phi over 2 plus iota sin theta minus phi over 2. Hence, comparing this with the standard polar form of the complex number, we can find that argument of z1 is theta minus phi over 2. Now we find the argument of z2. देखते हैं वो कैसे करते हैं. If we subtract these two, then if we subtract 2 from 1, then we can get 2z2 is equal to r is common, so from here we get cos of theta minus cos of phi plus iota sin of theta plus sin of phi. Now, again, using cos of a minus cos of b equal to minus 2 sin of a plus b over 2 into sin of a minus b over 2, and similarly sin of a plus sin b equal to 2 sin of a plus b over 2 into cos of a minus b over 2. We can write 2z2 equal to 2r into, from here we get minus 2r into sin of theta plus phi over 2 into sine of theta minus phi over 2. From this will become sine 2 minus 2 sine theta plus phi over 2 into sine theta minus phi over 2. And similarly, 2 will become, this is sine theta plus sine theta. This will become, you would take minus common, this will become minus iota sine of theta plus phi over 2 into sine of theta minus phi into cos of theta minus phi, because cos A minus B over 2, so cos theta minus. Now, if we take this sine theta plus phi, this is common. So we write, and 2 is common, cancel with 2. So we get Z2 is equal to minus sine of theta plus phi over 2 into sine of theta minus phi over 2 minus iota. This is common, so we get cos of theta minus phi over 2. Now, this is actually cos of, if we take minus inside the bracket, this will become minus and this will become plus. Now we again have two formulas in trigonometry, that sine of theta plus pi by 2 is equal to cos of theta over 2. Similarly, sine of cos of theta plus pi over 2 is equal to minus sine of theta over sine of theta. So this is theta actually. This is in formula. This formula. This is. So this is actually R there. So this is R sine theta plus phi over 2 into, this can be written as cos of theta minus phi over 2 plus pi over 2 and plus iota. This can be written as sine of theta minus phi over 2 plus pi. This implies that Z2 is a complex number whose modulus is R sine theta plus phi over 2 and its argument is theta minus phi over 2 plus pi over 2. Thus, we can write that argument of Z2 is equal to theta minus phi over 2 plus pi over 2. This is equation number B. Now it is very easy that we can write if we subtract, I would want to find the argument of Z1 minus argument of Z2, then this will become then difference will be pi by. Okay. So argument of Z1 minus Z2 modulus R argument Z mean difference, absolute value. The difference of two arguments is pi by 2. So we have, in this way we have proved that if Z1 mod is equal to Z1 plus Z2 modulus is equal to Z1 minus Z2 modulus, then The two are complex numbers z1 and z2 will be such that the difference of their arguments will be equal to pi by 2. Okay, so this is how you can easily prove that the difference of these two complex numbers z1 and z2 is pi by 2. आगे बढ़ते हैं, अगला क्वेश्चन करते हैं, इसको आप एक दफा दोबारा समझ लें. Next question is, show that equation of ellipse, we have to show that equation of ellipse having foci at z1 and z2. Foci are these 2 points, z1 and z2 are two foci of the ellipse, and major axis is 2a. We have to show that its equation is z minus z1 modulus plus z minus z2 modulus is equal to 2. Let's suppose that this is an ellipse. So major axis is 2a, means this is 2a. Let's suppose P of z be any point on this ellipse. Let's suppose that P of z be any point on this ellipse as shown in the figure. Now, two foci are z1 and z2. Let's suppose these are two foci, z1 and z2. This is f1 or f of which is z1, and f dash is second focus of the ellipse, and this is z2. Okay. Now we want to, these are 2 points, a and a dash. If it is f dash, it is a dash, and this is a, and the major axis is 2a, so a dash modulus is equal to 2a. Also, by the definition of ellipse, fp plus f dash p should be equal to a dash is equal to 2p. This is the definition of ellipse. Fp plus is equal to, this is equal to major axis. This is any point on the ellipse, we take the distance from the two focus and add them. This should be equal to the major axis. Now fp, this is z. fp is the distance from f to p, and f dash p is distance from f dash to p. So in complex number organ diagram, fp will be equal to z minus z1 modulus, and f dash p will be equal to z minus z2 modulus, and is equal to 2. Okay. Now this is the desired equation of ellipse we have proved. So z minus z1 modulus plus z minus z2 modulus is equal to 2a will represent an ellipse, having major axis equal to 2a and z1 and z2 as its two foci. Also, if we have to find the eccentricity, then we know that f dash is equal to 2ae. Now, f dash, what is f dash? f dash is equal to z1 minus z2 modulus is equal to 2a. So if we want to find the eccentricity, this will be equal to z1 minus z2 modulus divided by 2a. So in this way we can also find the eccentricity of the ellipse. So हमने शुरू कैसे किया था, हमने कोई एक पॉइंट ले लिया था ellipse पर. Now using the definition of ellipse that fp plus f dash p should be equal to major axis, and we know that fp is equal to the z minus z1 modulus by distance formula, f dash p is equal to z minus z2 modulus, so is equal to where this is the desired equation. Similarly, by the definition of eccentricity, we can find the eccentricity of the ellipse. Next question is, if z1 and z2 be 2 points, 2 complex number, then we will show that z1 plus z2 whole square plus z1 minus z2 whole square is equal to 2 into modulus of z1 square plus modulus of z2 square. This will we have to do, where z1 and z2 are 2 complex. इसको सॉल्व करना बहुत आसान है. हम क्या शुरू करेंगे, यूं करेंगे हम कि लेट्स सपोज z1 is equal to r1 cos of theta 1 plus iota sin of theta 1, or we can write it r cis theta 1, cos of theta 1 plus iota sin theta 1. इनको जरा मुख्तार तौर पर हम यूं लिख सकते हैं. Similarly, we suppose that z2 is equal to r2 cos of theta 2 plus sin of theta 2. So if we want to find z1 plus z2, how we find that? z1 plus z2 square. How we will find that? If we have to find z1 plus z2 square, then this will be equal to r1 plus r2 into cos of theta 1 plus cos of theta 2 plus iota into sin of theta 1 plus sin of theta 2 and we will have square. Understand? We want to find r1 plus z1 plus z2 first. अब कुछ है तो समझना है, मैं आपको पहले समझाता हूँ, थोड़ा सा इसको एलिबरेट करते हैं. We find z1 plus z2, real part into real part, and complex part into complex part. So this will become r1 cos of theta 1 plus r2 cos of theta 2 plus iota r1 sine of theta 1 plus r2 sine of theta 2. This is the z1 plus z2. If you want to find square of this or modulus, find the square of this or modulus of square of this, we know that if we have a complex number z is equal to x plus iota y, then its modulus square will be equal to x square plus y square. So if we want to find z1 plus z2 modulus square, then this will be r1 cos of theta 1 r2 cos of theta 2 square plus r1 sine of theta 1 plus r2 sine of theta 2 square. Now we want to solve it. We want to open it. If you want to open it, this will become r1 square cos square theta 1 plus r2 square cos square of theta 2 plus 2r1 r2 cos of theta 1 cos of theta 2 plus this will become r1 square sin square theta 1 plus r2 square sin square theta 2 plus 2r1 r2 sin of theta 1 sin of theta 2. Now if we take r1 square common, then we will get inside the bracket cos square theta 1 plus sin square theta 1 is equal to 1. So this will become r1 square plus similarly we get r2 square plus 2r1 r2 is common, and inside bracket we have cos of theta 1 plus cos of theta 1 cos of theta 2 plus sin of theta 1 sin of theta 2. This will be equal to cos of theta 1 plus theta 2. Okay. Theta 1 minus theta 2. Yeah, because alpha minus beta is plus. So this is how you get z1 square plus z2 square. Now similarly we want to find z1 minus z2. Similarly, we want to find z1 minus z2. This will be z1 minus z2 will become, we have minus here and we will have minus here. We want to z1 minus z2. Similarly, z1 minus z2 square will become this minus this का square. So we open this formula by this quadratic a minus b whole square. Similarly open this formula by a minus b whole square. So then we will have a minus here, other all things will be same. So z1 minus z2 modulus square will be equal to this thing, and we know that z1 plus z2 क्या था, ये हमारे पास z1 minus z2 का मॉडुलस स्क्वायर है, प्लस मॉडुलस का स्क्वायर हमारे पास आया था R1 स्क्वायर प्लस R2 स्क्वायर प्लस 2 R1 R2 cos of theta 1 minus theta 2. If we add them, this will be cancelled. So we'll get Z1 minus Z2 का स्क्वायर मॉडुलस स्क्वायर और एक ही बात है प्लस Z1 प्लस Z2 का मॉडुलस का स्क्वायर will be equal to 2 into R1 square plus R2 square. Now R1, what is R1? R1 is actually modulus of Z1. So this will become modulus of Z1 square plus modulus of Z2 square. So this is proved.